Hello, my name is Oliver Prochnow and I'm the CEO of VALO Innovations, which is part of the Photonics group. Within the group, we are responsible for the femtosecond lasers for Photonics. Today I will present you the VALO Femtosecond Series. The VALO Femtosecond lasers are unique lasers which can offer pulse durations down to 50 femtoseconds and a power level up to 2 watts. This means we can achieve a very high peak power. But why is this unique? So typically the spectral bandwidth of a femtosecond laser is limited by the so-called gain bandwidth. And this is a material given value. And the so-called Fourier-limited pulse duration, this is connected to the spectral bandwidth and gives you the minimum pulse duration of a laser. And with our lasers, we now found a new way to overcome the spectral bandwidth limitations. And this ends in a very short pulse duration. Typically, we can achieve pulse durations below 40 femtoseconds, which is typically a factor of 2 to 3 times smaller than what you can achieve with conventional lasers. We can offer 2 different versions of our lasers. So our so-called alto laser can offer more than 200 milliwatts at a repetition rate of 30 megahertz. Our tidal version is now able to produce more than 2 watts at the same repetition rate. Both lasers are able to produce typical pulse duration in the range of 30 to 40 femtoseconds. And both of them have a very good beam profile with a gauge with an M square in the range of 1.05 to 1.2. And all our lasers have an integrated dispersion precompensation module, which allows you to compensate dispersion in the beam paths like lenses. And due to this model, it's always possible to get the shortest pulse duration exactly at the sample where you need it. For an easy integration, both of our modules are completely passively cooled, so you don't need any water cooling, there's no fan, and you can just simply put the module on the table and start working. We now learned that we can offer very high powerful lasers with a very short pulse duration. That means we're able to produce extremely high peak power values. But why is this important? The main application for our lasers are multiphoton applications. One of the main applications here is multiphoton microscopy, which is based on the multiphoton absorption of light. So you can simply imagine that due to the very high peak powers, you can just increase the efficiency of a multiphoton process. For example, if we have a look on a 2-photon process, if we compare a 200 femtosecond pulse to a 40 femtosecond pulse, this means we can have a 5 times higher peak power, which gives you nearly a factor of 5 in the signal-to-noise ratio. On the other hand, that means if we want to have the same peak power on the probe, we can just lower the average power by a factor of 5, which means we do not heat up the probe. So cells can simply live longer because they are not heated. Further applications are in the field of optogenetics and 2-photon polarization, terahertz generation, and nanomaterials processing. These are all the fields where you can really benefit from the shorter pulses. If you want to learn more about our products, just go on our website.